Hey folks, welcome. Azure Cosmos DB Live TV, episode 56. We're going to talk this week about the Cosmos DB bindings for Azure Functions. And I've got with me this week, Marc Duiker, Azure MVP. You're Azure MVP, right?
Yes, exactly. Yeah.
Okay, Azure, because I know there's data platform, there's developer.
So many MVPs. Yeah.
There's like I think there's one for Office or whatever. I don't know what do they call it? Microsoft 365. I don't know. I don't know anything about those guys. But Azure. So Marc is here. Is going to talk us about these input-output bindings using .NET 6. How are you?
I'm doing very well. Yeah, I just had a nice couple of weeks of holiday, but now I'm getting back into business and also doing these streams and meetups again. So
that's great. I took a week off last week, but I didn't really do any holiday. My wife's parents will have to go back home. They've been with us since COVID started, but then they went back home, and so now I don't have any childcare. So I spent last week trying to figure out what am I going to do in terms of like dropping kids off and picking them up from school and all this other stuff.
All the logistics that can be challenging.
It was more of a week of just trying to sort out. Okay, now what am I doing, rather than anything restful. But that's okay. I'm back in the swing of things, and glad to be here. Let's talk about these input-output bindings you got. So got some slides here, I guess you're going to show us.
I got a couple of slides prepared, but most of it will be actually looking at the code and actually running the Azure function so we can actually see what it's doing. So let's get started. So I'm going to talk about the Cosmos DB bindings for Azure Functions written in .NET 6, and we're talking about the in-process Azure Functions, to be specific. So first I'm going to explain a little bit about Azure Functions and serverless architectures in general, and then we'll dive in straight into a couple of examples of output bindings. I have 3 different variations for you, and then we close off with 2 different variations of input bindings. So, well, these days, serverless architectures are all over the internet, and I've made a basic example of what happens when you make an HTTP post with some kind of payload. Then it's quite common that you do some kind of lookup, you read something from a Cosmos DB, you do some processing, that you put the result on a queue, and that message can be picked up with another function app, and finally you store something or you update something into Cosmos DB again. So this is quite a common scenario for many businesses. And there are many ways how you can read read your documents from Cosmos DB or update or manage them. And one of the ways is, of course, the Cosmos DB API, so the C# API or JavaScript API. But there are, I think, more elegant ways and even quicker ways for developers if you're working with function apps, and that's by using these bindings. So, okay, what are bindings? Well, if you look at an Azure function, what are all the components of an Azure function? So Azure functions always have triggers, right? Because they're event-driven. So that could be an HTTP trigger or a queue trigger. It could also be a Cosmos DB trigger, but that's not the topic of today. But next to triggers, there are these things of optional input and output. And these are the bindings. And these input and outputs, they are completely separate from the trigger. So we can have an HTTP trigger, but we can have then a Cosmos DB input. So whenever we receive an HTTP post command in our function, we can use some of that information from that HTTP request to also look up some data from Cosmos DB. The same goes for the output. The output is also completely unrelated to the trigger. So we can have an HTTP trigger, and then we can actually easily store some data to Cosmos DB. And that's what we're going to do. The link below here points to the Microsoft docs where these function bindings are explained for Cosmos DB. The documentation is nicely up to date. So definitely recommend you to read that. So now let's get busy with some code. So this is VS Code. I have a function app here. The function app, all of this code that you'll see is also in a repo, and we will also share the link to the repo so you can try it yourself. It contains more functions than Cosmos DB functions, but we'll focus only on the Cosmos DB functions now. There are some HTTP triggers in there. I got 3 HTTP triggers with some Cosmos DB output bindings, and I've got 2 HTTP triggers which use an input binding. And most of them are using a player class model, and that player, because it's like in a gaming context where you have
this is like a sports metaphor you're
doing. That could also be it. Either gaming or sports. That doesn't really matter. It's flexible. So it's a very basic class. It contains an ID, a name, an email, and a region. So a very, very lightweight class. And then this is the information that we are either putting in Cosmos DB or we are reading from Cosmos DB. So let's have a look at the first output binding here. So the store player Cosmos output. So this is the function definition. It's quite a short function, just a couple of lines of code. And what we'll see here is that it's an HTTP trigger, and it will respond when we do a post. And here you can see the reference to the player object. So we actually we have already a strongly typed input here, and we can do that because we use the .NET 6 in-process model here. So we're not working with the raw HTTP request or request data, so we can use the player object straight away. So this is the trigger, and then below the trigger is, in this case, the Cosmos DB output binding, and it needs a few pieces of data. So the first parameter here is the name of the Cosmos DB database. The second argument is the name of the Cosmos DB collection. And then you have to specify the connection string property. And what you have to know is that this is the name of the connection string. So a long time ago, when I just got started with Azure Functions and Cosmos DB, I thought this was supposed to be the actual connection string itself. But no, this is the name of the connection string that is specified in either in your local settings here, or is specified in your application settings once you have deployed your function.
That wouldn't be very secure now, would it? If we were
exactly, no, indeed, no. But
let's just go ahead.
That was my misunderstanding.
Source control. I'm sure GitHub will not mind, or whoever.
No, exactly. No. So it's a good thing to be aware of. So what this exactly is. And so there's this out argument here. So it indicates that. So we are talking about the Cosmos DB output binding. And we actually just giving back the same object. So we're storing a player object as the output. So what happens in the function is just really just this line. Actually, we're just assigning the input to the output, and that's it. And then we are returning an accepted result because we're doing an HTTP request. So the actual body of the function is just these 2 lines, and the rest is let's say the configuration of the trigger and the output binding. So with just a very few lines of code, you can configure easily storing your HTTP request object into Cosmos DB. So let's start running this function app, and let's actually run this. I'm running this completely locally, so I'm using the local Azure Functions runtime, but I'm also using the Cosmos DB emulator. So that allows me to run and test this completely locally on my own machine. I have to look up where it is. Yeah, this is the Cosmos DB emulator. So I already have a game DB here with a players collection, and at the moment, this collection is empty. All right, so the function is up and running. So now I want to do a post request to this function. I'm a very big fan of all kinds of extensions in the VS Code. So one of the extensions I am using is the REST client extension in the VS Code. So I have this HTTP files, and in these HTTP files, I can put things like this. So I can actually specify what kind of HTTP commands I do. So in this case, I'm doing a post to the store player Cosmos output function. And this is the payload I'm sending. So it's a JSON payload. It's an auto-generated ID, and then I'm providing a name, an email, and a region.
Oh, that's handy. You don't have to use like a service to basically do the HTTP post. I mean, and I guess if it's running locally, like what are you hitting? You can't really hit like your local machine. I guess from a
Yeah. Well, some people are. You can use any REST client, of course. I was also
Yeah.
a big fan of Postman before this, but
Yeah.
now I'm using mostly this REST client, and it's
That's
very
handy.
straightforward to use. And I'm saving all of these HTTP files in the repo as well. So you also have this test data and this test commands to test your Azure function. So I got back a 202 accepted, which means that the data should be in Cosmos DB. So let's have a look. I still need to refresh this. And yeah, here we go. This is the data that we've sent. So that's working. Excellent. So we can head over to our second example, and yeah, believe it or not, that's even a shorter one than the one before. This second one, it uses a bit of a weird syntax because we have the definition of the function name, but right below that we have a return Cosmos DB binding. So yeah, whenever I first saw this, I think, what kind of weird thing is this? But this is an alternative way to specify your output binding. Yeah, so it's not at the same places anymore. It's not below the trigger, but now it's actually above the method definition, right below the function name. So it's return and then the name of the Cosmos DB binding and then the same information. So we need to specify the database, the collection, and the connection string setting again. And now, the HTTP trigger is completely the same as before. And now the only thing we need to do is we need to return our input, and that's our player again. So I think this is really let's say the minimal implementation you can get away with by just simply storing the object in Cosmos DB what you are receiving.
I'm curious. So this is going to send over a post operation, though, right? Wouldn't this be a get?
Wouldn't this be a get? No, because this is an output, and we are putting some stuff in the body. So no, I'm not sure what the default response of this is now, though, because in our previous example we are.
Maybe I'm misunderstanding. So this thing isn't running and like grabbing a player and then returning that, and the response it's
no. It is still an output binding because of this return.
Yeah.
So we are not doing a get. We are actually doing a post.
Okay. Yeah. Okay. Sorry.
Yeah. So let's see this in an example now. The function app is still running, so we can go back to our HTTP file with our example. So this is the function we're trying to call. It's a different player name this time, and what we get back is a 200 OK. So that's the default what you still get back, although we didn't have to specify the response in this time. But now our collection should have a second record. So if you refresh this, yeah, and this is our second record with Ada Lovelace. So that's working as well.
Got it. It's very easy.
Yeah, exactly. But the thing that threw me off initially was that return prefix in this attribute, which is something that I wasn't familiar with. So the final example is when you want to insert multiple records. So again, we have an HTTP trigger again with a post, but instead of adding a single player, we now have an array of players that we now receive in the body of our HTTP request. And again, we use the Cosmos DB output binding, and we specify the database and the collection and connect string again. But what is different now is the type here, because before it was the player type, so a single record, but the type is now an async collector of type player. And this is a very, very versatile type that's also used with other bindings. But in this case, it allows us to add records to this collector, and the collector itself is then responsible for pushing the data or flushing the data to the output, in this case, Cosmos DB. So what's happening in the body of the function, we are just iterating over our input, and we are iterating over each player in the players, and we are adding that to this collector. And the collector will take care of the rest, so you don't have to worry about that.
Have you tried seeing how many records you could throw in a single request on this thing?
No. It will be nice to stress test this. No. No. I haven't gone further than I think
I'm always
like 50 or so. But you should use this with caution, I guess, because there are some max, or there are some limits, right, to what the HTTP stuff can handle.
I take special delight in trying to break stuff like this. So I'm gonna clone your repo here, and I'll put it back.
Try it. Yeah, exactly. Yeah.
I'll put this back up for folks here. But I'm gonna clone your repo, I think, a little bit later, and just see how much stuff I can jam in there until I blow up functions.
That would be a good crash test. Yeah, and even good test is maybe a bit easier. Is maybe not to pass in anything with the HTTP trigger, but just maybe create the players just in the loop here. Just do a loop from 1 to 1,000 and see if it works. Yeah, that sounds like a nice test. In this case, I have an example with only 3, so that will definitely work. So this is the array of players. So I'm sending it now. So now I expect 3 more records to be added in Cosmos. Get back to accept it. And let's have a look. And let's refresh this. So the last one was CO. Yeah, and now we have these 3 new records.
Yeah, very cool. Got a few questions from folks here. Oh, more of a comment from Sarah. Good thing pointing out that connection strength. I guess that tripped her up as well.
Yeah. I guess I'm not the only one. Yeah, exactly. Yeah.
I've actually seen that question on from folks in Stack Overflow. They're like, why isn't this working? And like because that's supposed to be a token for a environment variable. So
yeah, and to be honest, it is properly documented though. But yeah, if you don't read the documentation and just straight up go do something, then
who's reading docs? Only suckers read docs, right?
Well, yeah, exactly.
I'm kidding.
Well,
this is so. This is product side and database. I'm not quite sure what you're saying there, but this is all running locally. If that's your question, if this is live or on the service, this is all running locally with local functions emulator and storage, and also Cosmos emulator.
Yeah, exactly.
In there. So hopefully that answers your question. Oh, here's Sarah making fun of me again. So Azure. Look at Sarah. It's going to take more than me dorking around to bring down the service. It's been battle tested, battle hardened against numbnuts like me.
Exactly. Yeah. I think also DB can handle all these thousands of records easily. Indeed, it's probably probably HTTP limitation. Yeah.
That's the whole beauty of scale out architecture, folks. Is
exactly.
Don't have to worry. Infinite throughput. So, yeah,
exactly. This is just to give you a flavor of what's available on each. So definitely do some proper testing yourself, especially if you run into bigger numbers, which of course is also what serverless is for, right? So you should design it with the scalability also in mind. Of course, maybe you're starting a new business and business is really low initially, but maybe it will ramp up. And maybe when it ramps up, then you might run into completely different issues. So it's good to be aware of that.
So you're running these as you said. I see you said serverless persistence in there. So you're not running these in a premium function. You're running these on consumption plan, I guess. So
by default, yes, yeah. But one of the customers I was working for like 1.5 years ago, we had some different requirements, and then we were actually using the premium tier. So we would always have at least one instance running and less wait time for requests to be handled.
Is there have you had issues where calling an HTTP trigger on a consumption plan and it just didn't fire or didn't work, or you had to do it multiple times to wait for it to wake up? Or do you see any kind of hokey before or kind of
I never encountered it to be honest. No. But yeah.
I know it's slower because it's a cold start, obviously, if it's
exactly. Yeah. No, and I've seen people also playing around with some kind of warm up timer scripts and things like that, and there are ways around it, and a bit without even using the premium model if you want. But to be honest, if it really depends what your use case is, right? If you
right. Like I think I saw people use it. Was it Ping FM? What the heck was the name of that service? There was a service you could use that could use to ping an endpoint that would kind of keep the endpoint alive.
Right.
to
Yeah,
fake,
right.
to kind of get around having to pay the functions folks for a premium SKU in there. So I can't remember if it was that or some other thing people were using to try and fake it, but I don't know.
And if your requirement is really so high that you really need super quick responses, then you just need
use a premium.
You need a premium SKU, right? So need the right tools and the right SKU for the right workload.
Yeah, and there's no startup time for our serverless folks. Just want to point that out. So I'm not trying to needle anybody, but
good plug. Yeah, good plug.
It's there. Yeah, but we just don't have SLAs on latency or performance. They're all SLOs, if you will, right? So,
all right.
Performance is good. So very cool.
So these were my 3 examples for output. So I've got 2 examples for using the input bindings. So actually reading data now. So this is one of them. So again, we are doing an HTTP trigger, and now we are using
now we're doing a get. Okay, got it.
Yeah, and we've also specified the route now, and we are providing, or we require a region to be specified and an ID to be specified, because those are the 2 arguments that we actually need to do a point query. So we provide that when we make the request, and then this is our Cosmos DB input binding now. Again, we need to specify the database, the collection, the connection string. But now, since we are doing a read and we're doing a point query, we also need to specify the partition key, which in this case is the region, and we need to specify the ID of the document.
Interesting. If it was so that makes sense that you'd have the region and the path there, because the ID is going to be unique within that partition key. So that makes sense to do that. If it was a partition by ID, you would just have the path just to straight up to ID in your route there, right?
Yeah, exactly.
You don't have to put it in twice or anything. So
indeed. There are different flavors of how you can do this indeed. But this is just one of the many possibilities. Yeah. And we specify again what our type is here for what we get out of Cosmos DB, and we just give back an object result and providing that player as part of the payload. So it's actually a one-liner in the body of the function, and most of it is actually configuration of the HTTP trigger and of the Cosmos DB input binding. So let's run this as well now. But we actually need now an ID that's actually stored in Cosmos. So let me first have a look what our ID is. So for instance, if you want to retrieve this first record, we need this ID. All right. And let's go to our test file and overwrite this one. All right, so we currently specify a region, United States of America. We have our ID here, and this is the endpoint that we were hitting. This is a function, and we will provide the region and this variable and the ID, this variable. Okay, let's call it, and we get back a 200 OK, and this is indeed the record that we stored there. So that's also working nicely. All right, in case you want to do something a bit more complicated, then you can use another binding which uses the document client. So here we can see we still have the HTTP trigger. We're still doing a get, but now our Cosmos DB binding looks quite different. We're not specifying the database or collection here. We only specify the connection string here, and we're using the document client. And with the document client, you can do almost anything with Cosmos DB, right? So this is almost like falling back to the, let's say, standard Cosmos DB C# API, which also provides this document client. So what we're doing here with this document client is, first we are still extracting the region from the query, because that's our partition key that we need. And then we use the URI factory to get our collection URI. And then we are creating a document query using the document client and specifying the type, providing the collection query. some feed options where we specify the partition key. That's important. And then you can do some link statements where you can actually filter on some data. So in this case, I only want records where the email is not empty, and I'm actually projecting it. So I only get a collection of names back, and that's it. I don't want the full records, for instance. So here you can do as you please, and then play a bit more with the data. Also, I'm getting this back as a document query, and that will allow us to use this, because in case we have lots of data, we need to execute this in multiple batches. So we can do the query execute next async. And in this way, we can extract all of the names from this collection. So this is quite the opposite as the previous function, because the previous function was very simple. It was just one line of code, and it just gives you back the record for that ID. But this is exactly the opposite. You're using the document client, and you can specify all of the details that you want to filter the data and then massage and project the data to get it back in the exactly shape as you want. So now let's run this as well. So this is the URL that we are getting, and we're specifying the region here. So let's make this request. All right. And there will be some doubles, because there are some additional, there are some, let's say, duplicate documents with unique IDs, but still have some same data. So we have 2 records with Grace and 1 with Margaret. But at least you can see that the function is working.
Looks cool. I noticed that was using the v2.NET SDK in there. So that's from the function. That's coming from functions itself, right? So that's using the old v2.
Right. So there's a newer one. Yeah. Okay. Yep. So
they're still in preview though. I think we're waiting. I don't know why we're waiting, but there is a newer one.
All right. Yeah. Okay. Now that would be nice to update this. As well.
Hopefully later this year those things will be out. So better. Yeah. It's just faster, obviously, than using our V3 client. So you can deserialize data directly into a POCO rather than having to go into the document.
Nice. Yeah.
Client there. So
yeah. Okay. Cool. I'm looking forward to that.
Yep.
Nice. All right. Those are the examples that I have prepared for you. Again, mention the link where you can all get it. It's all out in the open. So as soon as there's a new Cosmos DB binding, a new NuGet package out there, then I'll definitely update this repo and make sure all the code is updated to work with all the latest bits, so everything is fast and performant as well. If you want more information about Azure Functions or how it can be used in your serverless architecture or with Cosmos DB, feel free to reach out on Twitter. I've also got a YouTube channel where I have a lot of videos on Azure Functions and durable functions. And again, my main GitHub profile for all of the open source stuff.
That's good. Is that 8-bit Marc right there on your slide there?
Yeah, exactly. That's one of my biggest side projects in it. Still doing.
Oh, you made that yourself?
Yeah, exactly. Yeah.
How do you do that? Is there like a tool that make 8-bit?
Yeah, exactly. Yeah, I'm using a tool called Sprite, and that's really dedicated for pixel art. But it's like a mini version of, say, Photoshop, but then completely dedicated for pixel art. So you can use all layers and different kinds of tools to shape and draw and make animations. And that's
really I think mine would be just pretty plain, just a big red or big round bald head.
I think yours would be quite easy to make.
Yeah, easy to make. Just basically take a bowling ball and put it on a stick figure. So
well, I've created a lot of avatars for lots of Twitter users. So
have you?
I'd be happy to make one for you.
Sure. I mean, I just got my picture. That's been the same one for like, I don't know, 4 or 5 years. So yeah, maybe I don't know. And people can say, "Wow, I wonder what that guy looks like." So,
it's nice to have a bit of mystery.
Yeah, right. That's right. Or a bit of surprise. Just a comment from Sarah here, like how you're using VS Code REST client for the demos. I agree. I'd never seen that before. That is pretty slick. You basically just click the little thing above the function. I mean, that's just great. Send request and boom.
Yeah, exactly.
It's done. That's very snazzy. I like that a lot. So is that an extension that you install in the VS code there?
Yeah, exactly. If you just search for REST, it's called the REST client, this one. So there are multiple REST client extensions, but this is the one that I'm using. So yeah, it's really nice. You don't need to context switch and switch to a different application to make the requests and things like that. So it's just nice. You can do it all in VS Code.
Does it handle like how do I like if I have to do authentication across the wire?
Yeah. You can add those to your. You can add some additional VS Code settings specifically for this REST client, and you'll have let's say another menu item here in this status bar, which allows you to switch environments. So you can have environment specific secrets if you have multiple accounts, for instance, or different credentials and things like that. So yeah, it all handles that.
Oh. I'm going to check that out. So I like we have a control plane REST API. I mean, we have a data plane, obviously, REST API.
Yeah.
But we have a control plane REST API, and I like to test against it sometimes. I will often use our SDK, the generated SDK clients, to do it, which is very easy. But in some cases, I actually want to drop all the way down to that. So
yeah, it makes sense.
If that's I use Postman, and it's okay, but it's sometimes cumbersome.
Like I said, I really like it. It's just plain text HTTP files or .rest files, which you can put in the same repo as where your other projects are. So it's all in the same place and easily shareable. And yeah, that's
cool. Yeah, look at and here anonymous LinkedIn user. So that's a good thing.
There are more fans. Yeah.
Thank you, anonymous LinkedIn user. Appreciate your vote of confidence there. So, all right. Well, Mark, thanks for joining us this week. This is very cool. Definitely learned a couple of things and saw some cool stuff as well in there. And hey, I hope you guys did too. So that's it for our show this week. A couple of things here. As always, I want to promote our user group that we run every month. So Jay Gordon over here on the team sets those up and gets awesome presenters and speakers to come and talk every month during our monthly meetup. So come and join us up on Meetup there. You can hit our page and join the group, and then join our meetup that we have every month there. It's AKAMS Cosmos DB user group. This is episode 56. So I've got 55 other episodes. What else are you going to do this summer, right? So we're at the end of summer here. If you're taking holiday and you're scratching your head wondering, God, what am I going to do? I don't know what to do with myself. We've got 55 hours nearly of online content for you to watch and check out. So why don't you just put down that Netflix and you can binge watch our show for 55 hours. And you can get lots of great information on there on that. So hold on, some questions. Just people saying thank you. So there's Sarah, thank you. And thank you. And thank you. Okay. Next week, we've got Blaze Stewart is going to be on. He's also another MVP and from Wintellect as well. And he's going to talk about anti-patterns on Cosmos DB, which I think is a pretty fascinating topic. I see quite a few people implementing anti-patterns in Cosmos because they sometimes just don't know what they're doing. So it's knowing what those are and keeping clear of them is super helpful.
Yeah.
So definitely join us next week for that. Again, Mark, great having you on the show.
Thanks.
You've been a great community buddy. I've had you. I think you've been on 2 of the Cosmos comps that I've organized, and always just awesome content. And you're just a great all around community person. So again, thank you so much.
My pleasure.
For everything. And everyone, thank you for joining us this week. And we hope to see you next week here on Cosmos DB Live TV. So that's it. Thank you very much, everyone. We'll see you.